Next on the agenda is problem 4. Here's problem 4. Find all solutions to the following equations. So I just have to solve 4 equations. This first one looks complicated, but it's a trick because we know that whenever you have a fraction set equal to 0, the only things that can make the fraction 0 are the things that make the numerator 0. So I have actually the fairly easy task of just solving x squared plus 2x minus 3 equals 0. And so can I factor this in my head? Yes, because this is x plus 3 and x minus 1, right? Okay, so the roots are x equals minus 3 and x equals 1. So A is done. Get out of here, A, you joker. And so let's see if B is any tougher. It is. Alright, so let me copy the equation. The equation is 27 e to the x equals 12 times 2 to the x. So there are several different ways to approach this problem, but let me do it this way. You just apply natural log to both sides. Whenever the x is in the exponent, that will almost always work. So what happens after you do that? You get ln 27 e to the x is equal to ln 12 times 2 to the x. Alright, and now do the properties of logs trick. This product becomes a sum, ln e to the x equals ln 12 plus ln 2 to the x. And now the whole point is that ln can reach up and yank the x variable out of the exponent, which is what we want. We want it down on the ground where we can deal with it. So this becomes ln 27 plus x times natural log of e. Natural log of e is 1, right? So it's just, this part just becomes x. And now I've got ln 12, and by the other law of logs, the x gets spit out here. Okay, and so now I just have a linear equation in x. Just need to solve this linear equation. So put all the x's on one side, put all the other stuff on the other. You get x minus x natural log 2 is equal to ln 12 minus ln 27, and so this is kind of, could do more cute laws of logs tricks here if we wanted to. This becomes x times 1 minus natural log of 2 by factoring. And let's do it. It's irresistible, right? This is the same thing as ln 12 over 27. Don't have to do that, but why not? It's fun. And so the very last thing is to divide both sides by this part, and what we get is x is equal to ln 12 over 27 divided by 1 minus ln 2. Okay, so slightly harder, but still not very hard. Okay, so let me push all this stuff down. So that's B. And let's take a look at C here. So C is also kind of, we would call it a logarithmic equation instead of an exponential equation, but it's the same trick, just using the fact that natural log and e are inverse functions. So let me write it down. It's ln x squared minus 3x is equal to 2. Okay, so how do you get rid of natural log? Well, you apply the inverse function, which is e to the x, to both sides. And so on the left here, you just get x squared minus 3x, and on the other side you get e squared. And so now I just have a quadratic function. So x squared minus 3x minus e squared. E squared is just a number, so I can use the quadratic formula. And so what happens, I get 3 plus or minus the square root of 3 squared is 9, minus becomes plus 4 times e squared, and this is all over 2a, which is just 2, and I'm just going to leave the answer like that. And great. Okay, so that's 3 down, 1 to go. come on down. Okay, and so this is a pretty easy move, right? You just write down cosine x equals square root of 2 over 2. And if you don't know by now, heaven help you. So what x makes this true? It's x equals pi over 4. Okay, it'll be plus or minus pi over 4 because cosine eats negatives. So I might as well make it plus or minus. And then because it's period 2, period 2 pi, I'm going to write n times 2 pi. And just so we're clear, I'm never comfortable with these until I draw a picture. I strongly suggest you do the same thing. Let's see, we're looking at a graph of cosine. Looks like this, right? And what did we just solve? We just solved cosine equals square root of 2 over 2, which we'll just say is the height of this line here. We'll say that the height of this line is the square root of 2 over 2. Alright, and where's one period of cosine? So here's one period of cosine between the x-axis and 2 pi. And let's just make sure we found all the solutions. So what I did was I used plus or minus pi over 4. So which ones did that give me? That gave me this solution and this solution. Okay, and within this one period you can see that there's another solution over here, but that's really the same thing as this. And so yes, I have got all the solutions. You only need to check one period, right? Because everything else is a copy. And we're done with number 4.